In number 7, we're going to practice our graphing. We're looking at the function f of x is equal to 9 minus 3 to the power of x plus 1. Okay, so exponential function. How do I know? Because there's an exponent and the variable is in there. Exponential functions, remember, look like a variation of this. So obviously they can be reflected. They can be reflected over the y-axis, the x-axis. They can look differently, but in general, they all have horizontal asymptotes. They don't have vertical asymptotes. So for the first part, part A, our horizontal asymptote, another good rule of thumb is the horizontal asymptote for an exponential function comes from the constant that you are adding or subtracting. So we have this 9 that is being added to the beginning of the function. That means I have a horizontal asymptote at y equals 9. Okay, next up, x and y intercepts. So x-intercepts, we set y equal to 0, we solve for x. So I'm going to get 0 is equal to 9 minus 3 to the power of x plus 1. Okay, subtract 9 from both sides. That gives me negative 9 is equal to negative 3 to the power of x plus 1. All right, I'm going to go up here. Because they're both negative, I can divide by a negative 1 and get 9 is equal to 3 to the power of x plus 1. How do I solve this exponential function? I get my bases to be the same, right? So I'm going to rewrite 9 as 3 squared. And now I have 3 squared is equal to 3 to the power of x plus 1, which means I can just set my exponents equal to each other and solve for x. So I get x is equal to a positive 1. All right, y-intercept. We set x equal to 0. So I'm going to get y is equal to 9 minus 3 to the 0 plus 1, which is really just 9 minus 3 to the first, or 9 minus 3, or 6. So my y-intercept is at 6 or 0, 6, which reminds me, x equals 1 is the value, but I would specifically say this should be the 0.10. Blech. Okay, let's make a table. So in part C, we want a table of values, and I'm given the x values I want to plug in. Okay, so my equation is 9 minus 3 to the power of x plus 1. So if I plug in negative 2, I'm going to get out 9 minus 3. Negative 2 plus 1 is negative 1. So 9 minus a third, or 8 2/3. Okay, so that is the point. Negative 2, 8 2/3. All right, next, 9 minus 3 to the minus 1 plus 1 would be 9 minus 3 to the 0, or 9 minus 1, because 3 to the 0 is just 1. So my answer would be 8. So I'm looking at the point negative 1, 8. For 0, I have 9 minus 3 to the 0 plus 1, or 9 minus 3 to the first. 9 minus 3 is just 6. So I'm looking at the point 0, 6. 9 minus 3 to the 1 plus 1 is really 9 minus 3 squared, or 9 minus 9, which is 0. So I have the point 1, 0. And last, 9 minus 3 to the 2 plus 1 is 9 minus 3 cubed. 9 minus 27 is a negative 18. Whew. So we got real small real quick. So 2 minus 18. Okay, use our answers above to sketch a graph. All right, so we said we had a horizontal asymptote at y equals 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The benefit of drawing the graph as you go is you can make it exactly as high or as low as you need. Okay? All right, let's plot my intercepts. I found those. I had the point 1, 0, and I had the point 0, 6. 1, 2, 3, 4, 5, 6. Okay. And then let's use the other points that I plotted. So -2, 8 2/3, -1 and 8, 0, 6, 1 and 0, 2, -18. That's totally off the page. So I can see if I were to connect the lines I had, it's going to go down, 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 down. And then when I get up, 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 I'm going to hug this asymptote up here. So here is my graph of f of x. All right, and then finally finding the inverse. So my original function was 9 minus 3 to the power, sorry guys, I forgot what it was. 9 minus 3 to the power of x plus 1. How do I find the inverse? Well, I change f of x to y, and then I swap my x and y values and solve for y. So first thing I'm going to do is move the 9 to the other side. So I get x minus 9 is equal to -3y plus 1. Then, because I don't like dealing with this negative, I'm just going to divide everything by a -1. So this would be -x plus 9 is equal to 3 to the y plus 1. Okay, so how do I get the y out of the exponent? I take log base 3 of both sides. And when I do that, on the right side, they pretty much cancel each other out and you're just left with the exponent. On the left side, I just have the 9, -x plus 9 in the log base 3. And then solving for y, I get y is equal to log base 3 of -x plus 9 minus 1. Domain and range. Well, let's sketch this graph. So remember, to sketch the inverse, we can just swap the points. All these points that we found in part C, if I want to plot the inverse, I'm just going to swap them. So I'm going to have 8 2/3 and -2, 8 and -1, 6 and 0, 0 and 1, -18 and 2. All of these points are on the inverse function. So let's do this in red. So 8 2/3 and -2. Oh boy, 1, 2, 3, 4, 5, 6, 7, 8. 8 2/3 and -2. About here. 8 and -1. Here. 6 and 0. Here. 0 and 1 here. Negative, oh boy. So if I connect the dots that I have, I get this shape. That's going to continue going in that direction. And then this horizontal asymptote is actually going to become a vertical asymptote at x equals 9 for my inverse function. So my graph is going to follow that asymptote. So I have a vertical asymptote at x equals 9, no horizontal asymptote. The domain of my inverse function, if I just look, it looks like I go from -infinity up until x equals 9. Don't include it because it hits that asymptote. And then my range